Yeah. In part 3, I was discussing control loop paradigm, okay, and hysteresis, and also like how Kubernetes goes with the event driven implementation instead of polling, okay. So in this live stream, like I won't be reading book on the spot. I have already read, so I would be summarizing the remaining parts. Okay, so as I'm also learning, yeah, I thought it would be good to summarize only like instead of reading. It would unnecessarily waste of time. So I'll be discussing like components of Kubernetes controller, okay, and also like what are the custom resources, custom controllers, and how do we define custom resource. Okay, so what are the tools available to manage service mesh, okay, and yeah, that's all, like the chapter ends, okay. So and we'll be seeing the next chapter after summarizing this in another video. So, so what does a Kubernetes controller? So usually a Kubernetes has multiple controller, and each controller uh, tries to control multiple containers of the same service. And yeah, that's the thing. And what does the controller has? Okay, so let's see what does the controller. So controller has a controller has a informer, okay, or watcher you can call, and a worker queue and dispatcher, and third component is the worker. Okay, so you would have already seen these worker queues in like a regular patterns in most of the blockchains or any other software where they use a queue as soon as a packet comes to process, they will put it in a queue, and they will launch few threads, those are called workers, and work will be given to those, okay. So the pattern is similar here as well, okay. So what happens is observer or watcher in Kubernetes controller will look at the state of the containers, and they try to like send the event, okay, if there is a change, okay. Instead of like pulling the controller, like it just does a event, it takes a event driven approach, the controller, okay. And as soon as the event is emitted, like it will go and sit in the, it will add a item in the worker queue, okay. And the dispatcher, so usually most of the times when there is a new item in the queue, it means that desired state needs to be achieved of what developer or software engineer has specified. So the dispatcher tries to check what is the current state of the system, and also checks uh, what is the desired state, okay. And it tries to launch appropriate worker, okay. So worker will go and modify the state accordingly, and this whatever this controller, no, like there is some sync period, okay, resync period. So within the resync period, it will try to remove its cache and load a new cache, new state of the containers, okay. And yeah, so that's the how components of Kubernetes controller work together, okay, to try to like this is the control loop that we were talking about in previous videos, okay. So those are live and bit lengthy, yeah. And Kubernetes also gives you like a chance to write your own controller, okay, like a custom controller, and also custom resources, okay, which can talk externally to any ecosystem outside of Kubernetes. Okay, if you have any resources or containers outside Kubernetes, yes, you could speak, so it will give facilities, and you don't need to do most. So you need to just write a application related code. You don't need to write anything that is repetitive or so common in controller or worker queues. Okay, so that's what a kube controller manager does. So it tries to give you a framework where you could write whatever you want. And coming to Kubernetes custom resources definition, like yeah, for suppose your application wants to speak to like multiple databases. In that case, like or whoever under the control of the applications wants to speak to multiple controllers. So you might need multiple databases. So like you could define some middleware in between which can speak to multiple databases, okay, with the same kind of queries, okay, so which will translate to appropriate database thing. So like what they call it as a proxy service, okay, so you could do this, but thing is you need to maintain that proxy service, okay, or containers of proxy service. But you really don't need to, like Kubernetes will give you the framework to write your own language, okay, without needing to manage service. It will only manage the proxy service for you. And also, like apart from Kubernetes, we might need additional tools, okay, to manage the services. Like the additional tools might provide things like security and health check and discovery, okay, and also like you could deploy the applications across some multiple data centers. So those additional tools will give. So some of the examples are like HashiCorp console and Istio and Linkerd, okay, from Cloud Native Computation Foundation. And so the main reason you could think of when you when like let's say you want, when do you want to decide like you need to use the additional tool? Like if you want to use more secure communication in between Kubernetes services, yes, you need additional tools, so you could explore them. And there is something called reactive or dynamic planning. So it is a definition, I think. So the thing is like sometimes a constant. So the workers are trying to change the environment to achieve the desired status. So sometimes if the change of state is constant, then it may take a bit longer. So you might need to plan in a reactive way. So if it is going so slow, then yeah, try to improve your specifications, okay, so that it matches the, it reaches the desired state, okay. But make sure like the hysteresis is not that is delay between queues and the processing, okay, so let the processing happen, then only you try to read the state again and perform the action. That's the thing. And there is a goal like called operator pattern. Okay, so what does operator pattern means? Okay, so like so most controllers like usually they handle routine repetitive tasks. So like it would be like better if a controller can do whatever a human operator like identifying the issue and issue or any problem, and it tries to suggest a solution, and it tries to deploy and keeps on working on its own, which is nothing but we call as artificial intelligence. Okay, so that you don't need human operator, it takes decisions on behalf of human operator on similar level or better level. Okay, so that's what they call AI ops. So, yeah, like if you want something like that, you need to see what are the products available in the market related to AI ops. So in the container management or container orchestration stuff, okay, you might need additional tools or something of that sort for managing containers, like deploying new ones or deleting the existing ones. So that's all, and I'll just discuss the summary. Okay, summary of this chapter. So here it is summary. Okay, so the summary is like you have a traditional distributed system, and where you need to like have a single monolithic applications, okay, deployed in known locations. Okay, and they don't scale or anything of that sort. You need to run manually multiple times. Okay, and the program will keep running until the system reboots. Okay, whereas in cloud native, like you need to, the containers are deployed in different locations based on load and stuff, and also the program is not monolithic, they are microservices. So there could be like you need to instantiate multiple instances of each microservice based on the load and stuff. And so how do the system manager or IT, so whoever the person assigned to see to keep the uptime more. So there should be IT admin should be allocated. So how will he manage? Okay, in this case, because it would be huge. Okay, it's not something you could manually sit and do. So there is some concept called as control loop. Okay, so like where control theory, where you need to like keep pulling the changes. Okay, and see if the desired state is achieved. Okay, whatever like uh, desired state of what software engineer has specified. So and it tries to keep looping in indefinitely. Okay, with a hysteresis or a delay between. Okay, so that's the thing, like that's how control loop works. It tries to keep checking the state and all. But you could do something called event driven approach, where you don't need to keep trying to or something. Like instead, whenever there is an event emitted, then you could tries to like Kubernetes tries to what react to the system. Okay, uh, with whatever action needs to be taken to achieve desired state. And that's the thing. And also Kubernetes provides with a set of controllers. Okay, as I discussed. Okay, and each controller will manage a set of pods or containers, and And we have discussed like what are all the components of a container, and what do they do. Okay, so how do they do this control loop thing with delay, okay, with the event driven approach. And and also we have discussed how you could define your custom resources, okay, or custom controllers in case if you want to do that. And finally, we need AI ops for more advanced automation. Yeah. Yeah, that's it for the day. And in the next video, we will go to the chapter 14, which is serverless computing and event processing. So yeah, thank you. Bye.